Hello everyone, here I welcome you all to Edureka's yet another tech enthusiastic video, and today we'll be discussing about CCA 175 Certified Spark and Hadoop Developer. Now, before we get started, please subscribe to Edureka's YouTube channel and hit the bell icon to never miss an update on the most trending technologies in the year 2020. Let's get started. Firstly, let's have a quick peek on the agenda for today's discussion. The first in the docket is, what is CCA 175? Here, we will discuss what exactly is CCA 175 and its importance. Later, we shall enter into the CCA 175 exam details, where I'll explain some important points about CCA 175, which includes the crucial aspects of the exam like time limit, the number of questions asked, etc. Followed by that, we shall move ahead into some significant points to be remembered in CCA 175 exam. Later, we shall also discuss the exam format, or the percentage of questions divided per topic through a pie chart. Once we are finished with the exam details, we shall enter into the skills required to attend this particular exam. After we are done with the skills, we shall understand why exactly the Edureka CCA 175 training is considered to be an outstanding course compared to others. Followed by that, we shall discuss the job and salary trends of CCA 175 Certified Hadoop developers. To make things interesting, we shall also try to solve one of the problems from the CCA 175 exam papers. And finally, we can wind up this session by discussing the top companies that are having a higher demand for CCA 175 Certified Hadoop developers. I hope we are clear with the agenda and good to go ahead. First up, what is CCA 175? Let me reveal to you the very abbreviation of CCA. It stands for the Cloudera Certified Associate Spark and Hadoop Developer. It is basically an exam which is dedicatedly designed and hosted by none other than the Hadoop flag bearer and the big data giant, the Cloudera. The major objective of this exam is to make sure to upgrade the skill set of Hadoop developers and to search for the most formidable skills in them by challenging them with questions that can test their very potential to the extreme. This particular exam can be taken up by any graduate or a professional who has some extraordinary Hadoop development skills. We shall discuss more on this topic in the further sections of this tutorial. Now, let us move ahead into the next part where we will be discussing some of the major CCA 175 exam details. The first and the foremost detail that we all need to observe is this exam is totally designed to test the Hadoop developers based on three technologies. Those are Apache Hadoop, Apache Spark, and Scala programming language. Let us go through a brief definition of all these three. Firstly, Apache Hadoop. Apache Hadoop is a powerful software framework designed to provide distributed storage and processing system. It is an open source software designed and deployed by Apache Foundation. To know more about Apache Hadoop, you can go through the playlist which will guide you through the Hadoop tutorial from Edureka. Followed by that, we shall discuss the Apache Spark. Apache Spark is a lightning-fast data processing tool used on top of Apache Hadoop Distributed File System or HDFS. It is an open-source data processing tool developed by Apache Foundation. To know more about Apache Spark, you can go through the video playlist on Apache Spark by Edureka. Lastly, the Scala. Scala is an advanced programming language developed using Java programming language. It is used to execute data processing commands in Spark on top of Hadoop. To know more about Scala programming language, you can go through the video tutorial on Scala programming language by Edureka. Now that we know the core topics based on which the questions will be asked, we shall dig deeper and understand the further details of this exam. Firstly, the number of questions that will be asked in the exam CCA 175. So basically, this exam is designed to have any number of questions between 8 to 12. And you will not be provided with any additional or standby questions that you might supposed to leave. Basically, you have to attend all the questions asked. The questions will be purely performance-based. That is, they are purely hands-on tasks on Cloudera Enterprise Cluster. Moving ahead, the next important detail of this exam is you will be provided with only 120 minutes. And believe me, you have to attend all the questions within the allocated time. No matter what, you will not be given any extra time to answer your questions. Next, The cutoff scores to get certified. The Cloudera expects you to score at least 70% in the overall performance to officially certify you as the Cloudera Certified Associate Spark and Hadoop Developer. Lastly, we come to the price tag at which you can book yourself a slot to attend this exam. This examination would cost you around 290 to 300 US dollars, and converted into Indian rupees, it would be around 21,000 Indian rupees or 22,000 Indian rupees. This is my personal suggestion to all the viewers who are interested in taking up the CCA 175 certification exam. We all know that apart from every other thing, time plays a very important role, and to succeed, we all have to manage and utilize our time in the best way possible. So here, I have prepared an overview to partition the provided 120 minutes in a really simple but strategic way. Firstly, you have to remember that you'll be provided with only 120 minutes. I suggest you to dedicate 10 minutes to decode your questions. Once you decode your questions, count the number of questions given in your question paper and divide your time evenly to all the questions. And finally, the most important thing is to reserve at least 10 minutes for cross-validation of your answers. Now that we have discussed our key points in time management, let us discuss how to prepare for the exam and how is the syllabus categorized. My suggestions on the preparations would be as follows. Firstly, we all know that CCA 175 exam is completely a hands-on exam. That is, you need to write a code to get desired result, and hence practice is the only way to prepare. Followed by that, the next important point is you can overlook the theory like Spark DAG, memory management, etc., which are completely theoretical and will not be asked in the exam. If only focusing on the exam is right now, this key aspect would be necessary to overlook the theory part. Followed by that, scoop import, export, Hive DDL, Spark transformation and actions, and Avro tools are the only topics you need to study, because major part of the questions will be based on these topics. The next important point is, if you practice well before exam, then you will find the most of the questions are based on very basic knowledge. So I suggest you to make sure that you practice well before the exam. Later, the next important point is, for questions on Spark, code file, which is for both Scala and Python, will be provided along with the questions. So when you're attending the exam, the code file for both Scala and Python will be provided to you. Using that, you can answer the questions. And the last and the most important point to remember is, you only have to fill in the blanks with appropriate Spark transformations and actions and run it through the shell script, which will also be provided. So it means that some of the questions will be asked in the format of fill in the blanks. We need to fill in the blanks with appropriate transformation and action codes, which you have to fill in those blanks and run the same code on the shell script, which will also be provided to you. Now with this, let us move ahead and discuss the syllabus distribution of this exam. Now let us suppose that the average number of questions asked in a particular exam are 10. Then, according to the distribution of syllabus, you will face one question from Avro files, two questions from Spark plus Python, two questions from Spark plus Scala, and two questions from Scoop, which are based on import and export data, and finally 3 questions from Hive, DDL, partitioning, etc. So basically what I mean to say is, Cloudera asks you 10% of the questions based on Avro files, 20% of the questions based on Spark and Python, 20% of the questions based on Spark and Scala, 20% of the questions based on Scoop, and finally 30% of the questions based on Hive. So this is how the questions will be categorized. And all these sections are important for you to get certified in the exam. Now, it's time for us to quickly discuss the major skills required to attend this exam. Firstly, the data ingestion. This stage includes the following. You will be asked to import data from MySQL database into HDFS using Scoop. And followed by that, you will also be asked to export data to a MySQL database from an HDFS using Apache Scoop. Later, you have to change the delimiter and file format of data during import using Scoop. Ingest real-time and near real-time streaming data into HDFS using Flume. And lastly, load data into and out of HDFS using Hadoop file system or FS commands. So these are the skills you require when you are working in data ingestion. Followed by this, the next crucial skill is to transform, stage, and store. Here, you might be asked to load data from HDFS and store the results back into HDFS using Spark. You may also have to perform join disparate datasets together using Spark. Later, you might also have to calculate aggregate statistics using Spark, example, average or sum of the complete column. Followed by that, you may have to filter data using smaller datasets using Spark. Finally, you should be able to write a query that produces ranked or sorted data using Spark. Next, we come to data analysis. Here, you will be asked to read and create a data table in a Hive metastore in a given schema. Here, you will be provided with a pre-designed schema. Using that, you have to create a new table. Next, extract an Avro schema from a set of data files using Avro tools. After that, create a table in the Hive metastore using the Avro file format. After that, create a table in the Hive metastore using the external schema file. Once after you finish that, you have to improve your query performance by creating partitioned table in the Hive metastore. And finally, you will be asked to evolve an Avro schema by changing JSON files. So these are the most important and major skills required to attend a CCA 175 exam. Along with this, let us also discuss some of the basic and core Hadoop skills required to attend for a CCA 175 exam. First up, you need to have a strong grip on the Hadoop ecosystem. Understanding the basic suite that provides the solution to big data is mandatory. The basic components of Hadoop, which are the HDFS and MapReduce, should be learned. Later comes the data processing tools like Hive, Pig, Scoop. And finally, mastering the data management and monitoring tools like Apache Flume, Zookeeper, and Oozie will be mandatory. Followed by that, you should be comfortable with Linux. Suppose if you're stepping into the world of Hadoop, then chances are there that you might start learning Hadoop using any of the popular distributions like Cloudera CDH and Hortonworks HDP. These platforms will help you speed up learning by providing a tailor-made platform where most of the services in Hadoop ecosystem are already running. You can start writing MapReduce jobs right away. These distributions may use one of the Linux flavors. For example, Cloudera CDH uses CentOS. Having some comfortable understanding of Linux and its flavors will help you to smoothen your learning curve. I strongly recommend gaining some competency in Linux while or before learning Hadoop. Followed by this, the next important skill is to have some hands-on experience with Hadoop core components. Hadoop is the technology that the future relies on. Hence, making real-time and data-driven decisions happen to be a crucial move. This can be only achieved when you get real-time hands-on experience with Hadoop components. Followed by this, the next important skill you need to have is to develop and implement Hadoop jobs with optimum performance. The main motto of Hadoop is to provide high-performance oriented data systems. This can be done by coding the data processing algorithms like MapReduce in an efficient way and balancing the load amongst the all available nodes in a cluster. The next important skill is to have the ability to load the data from different sources. Data is being generated every single second. The sources are limitless, and every single piece of electronic equipment generates data. Starting from the sensor to the satellite, Hadoop ecosystem should be capable enough to load the data from multiple sources for the domain it is designed for. After that, the next important skill is to be able to design, build, install, and configure Hadoop ecosystem. Although CCA 175 exam won't ask you to set up Hadoop in their systems, I would prefer you to have the skill as it helps you to have basic understanding of all the Hadoop components. Followed by this, you should be having the ability to translate complex technicalities. Hadoop is the most widespread technology used in global level, and different companies using it have their own requirements. A Hadoop developer should be capable enough to decode the requirements and elucidate the technicalities of the project to the clients. Next important skill is to be able to analyze vast data storages and uncover insights. Hadoop is undoubtedly the technology that enhanced the data processing capabilities. It changed the face of customer-based companies. Based on artificially intelligent systems, it is now possible to identify customer requirements and make decisions with little human interaction. It becomes a crucial role for every Hadoop developer to own a skill to analyze and generate respective reports based on collected data. Followed by that, we have security. Similarly, CCA 175 will not ask you to secure their cluster, but having a sound ability to secure the Hadoop cluster would be an added advantage to your resume. Followed by this, you should be having some high-speed data querying ability. The major role of any Hadoop developer is to make sure that there is enough memory on both query end and the server end. The buffers, indexes, and the joins play a key role while dealing with the huge amount of data. In case, if enough memory is not available to the system, then there are possibilities that the system might tend to go slow. Followed by this, loading, deploying, and managing data in HBase. HBase is designed and developed to host huge tables of data for interactive and batch mode analytics by running NoSQL on top of Hadoop. Its parallel data accessing capability in distributed systems make it the most capable, fastest, and scalable store for Hadoop framework. Having sound knowledge and working with Hadoop HBase would be an added advantage to Hadoop developers' resume. And finally, the cluster coordination through Zookeeper. Apache Zookeeper provides the best-in-class service to connect, coordinate, and maintain a Hadoop cluster. It gets in synchronization with all the nodes in a cluster using the most robust techniques and providing the simplest user interface. Being comfortable with Zookeeper services would be beneficial for a Hadoop developer to design any Hadoop cluster with strong connectivity. So these were a lot of skills discussed. So let's have a quick recap and move ahead into the further parts of today's discussion. So basically, you need to have a complete knowledge of Hadoop and its ecosystem. You should be able to work with Linux and execute some of the basic commands. Then Hadoop technologies like MapReduce, Pig, Hive, and HBase should be learned. Then you should be having the ability to handle multi-threading and concurrency in Hadoop ecosystem. Followed by that, you should be having a good familiarity of ETL tools and data loading tools like Flume and Scoop. Then you should be experienced with scripting languages like Pig Latin. And finally, you should be having some good knowledge of query languages such as HiveQL. So these are the key skills you require to attend CCA 175 examination. Now with this, let us enter into the next part of today's session, which is based on Edureka's CCA 175 Certification Training Program. Edureka, since its origin, is being committed to provide world-class training and certification to its students and make them industry-ready. Lucky for you, we at Edureka train our Hadoop students in such a way that they are ready to take up the CCA 175 certification. Because we designed the syllabus keeping CCA 175 in mind, and the best part is that the training will be handled by the real-time Hadoop experts from top industries. And now, we shall discuss the features of Edureka CCA 175 training. The salient features of Edureka CCA 175 certification and training will include the following. Firstly, you will be having instructor-led sessions, which will be including 36 hours of live instructor-led classes, weekly 12 sessions of 3 hours each, or you can also choose 18 sessions of 2 hours each, which will be held on weekends. The next one is real-life case studies. Live project based on any of these selected use cases involving implementation of various Spark and Scala concepts. Followed by that, you will be having assessments. Each class will be followed a quiz to access to your learning. Followed by that, we will be having a forum where we have a community forum for all our learners that further facilitates learning through peer interaction and knowledge. Followed by that, you will be having a lifetime access. You will get lifetime access to LMS where presentations, quizzes, installation guide, and class recordings will be available. Next, 24/7 expert support. We have lifetime 24/7 online support team to resolve your technical queries through ticket-based tracking system. Followed by that, certification. Successfully complete your final course project and Edureka will certify you as an Apache Spark and Scala developer. And finally, we have a Cloud Lab. Cloud Lab has been provided to ensure you get real-time hands-on experience to practice your new skills on a pre-configured environment. These are the few of the important and salient features of Edureka CCA 175 Training and Certification Program, and link to the Edureka certification program is dropped down in the link in the description box below. Now, moving ahead, we shall discuss the salary trends of CCA 175 Certified Hadoop Developer. We all know that Hadoop Developer is one of the most highly paid profiles in the current IT industry compared to other profiles. Today, we here have some of the most highly paid profiles with us, and we're going to compare them against Hadoop based on salaries offered per annum. So, the profiles are professional services, application and analytics, storage, computations, SQL, data management, networking, NoSQL, and finally, the Apache Hadoop. As you can see, the bar chart here depicts a gradual rise of salary of Hadoop developers from the year 2012 to 2020. We can also predict some decent salary growth of Hadoop developers in the near future as well. Let us now move ahead and also discuss the salary trends of Hadoop developers in different countries. Firstly, we have India. As you can see, for an entry-level Hadoop developer in India, we have salaries starting from 4 lakhs per annum to 5 lakhs per annum. On the other hand, for an experienced level Hadoop developer, India offers around 45 lakhs to 50 lakhs per annum as their annual salary. Moving ahead, the next country we have is the England or United Kingdom. The United Kingdom offers the salary of £25,000 to £30,000 per annum for an entry-level Hadoop developer. Similarly, for an experienced level Hadoop developer, England offers about £80,000 to £90,000 per annum as their annual salary. Moving ahead, the next country in the comparison is United States of America. As you can see, for an entry-level Hadoop developer, United States of America offers around $75,000 to $80,000 per annum as their annual salary. Moving ahead, for an experienced level Hadoop developer, United States of America offers around $125,000 to $150,000 per annum as the annual salary of a Hadoop developer. Followed by the salary trends, now let us discuss the job trends of Hadoop developers. As you can see, according to the current trend of IT market, there is a gradual growth in the job trends of Hadoop developers compared to other technologies like Java and Python. We shall get into some facts and figures about this growth of job trends in Hadoop. The number of Hadoop jobs has increased at a peak rate since last few years. We have seen about 50,000 vacancies of Hadoop developers that are only available in India. There are more in other countries too. Followed by that, India is the contributor of 12% of the Hadoop developer jobs in the worldwide market. The number of offshore jobs in India can increase at a rapid pace due to outsourcing. Followed by that, many big MNC companies in India are offering handsome salaries to Hadoop developers. 80% of market employers are looking for big data experts. The big data analytics market in India is currently valued at $2 billion and is expected to grow at a CAGR of 26%, reaching approximately about 16 billion by 2025, which makes India to share approximately 32% of the overall global market. This contributes 1/5 of India's KPO market worth 5.6 billion. Also, the Hindu predicts that by the end of 2019, India alone will face a shortage of 3 lakh data scientists. This presents a tremendous career and a growth opportunity in big data. The following chart depicts the skill gap. This skill gap in big data can be bridged through comprehensive learning of Apache Hadoop. This will enable professionals as well as freshers to add valuable big data skills to their profile. Now, let us discuss the major sectors where Apache Hadoop is being used. Apache Hadoop is being used extensively in the following sectors. Firstly, we have travel and tourism sector. Followed by that, we have online marketing sector. Next, we have banking and finance sectors. Followed by that, the next important sector is the medical and healthcare sector. Also, the ads and promotion sector. Later, the multimedia sector. Followed by that, we have biotechnology and biosciences sector, which use Hadoop in a rapid rate. Followed by that, we have natural resources sector. Next, we have government and military sector, which uses Hadoop for highly confidential data. And finally, last but not the least, the telecommunications sector. Now that we have discussed all of these, let us enter into the most interesting part of today's discussion, a sample problem from CCA 175 certification exam. The details of this particular sample problem are being mentioned in the Edureka CCA 175 training and certification article, and I'll be leaving the link to the article in the description box below. Let me now redirect you to the article to see the problem statement. As you can see, this is the article based on CCA certification exam from Edureka, and this is a problem statement. As you can see, the problem statement is divided into 8 sub-questions. So we will be solving all these 8 sub-questions. The first sub-question is, using Apache Scoop, you have to import orders table into HDFS to the folder location user Cloudera problem 1 statement. The file should be loaded as Avro file and use snappy compression. According to the syllabus discussion that we made before, we find this particular sub-question to be from Avro files. So here, we need to import the order table into HDFS and compress it using snappy compression. Following that, the second sub-question is, using Apache Scoop, you have to import order items table into HDFS to the folder location user Cloudera problem 1 order items. As you can see, this subdivided problem is similar to the first one, but the only difference is here you're importing the order items table in place of orders table, and you're locating this particular file into a new location, which is user Cloudera problem 1, and the new file is order items. Followed by that, you have the third question. In the third question, we have Apache Spark Scala. So according to the syllabus, this third subdivided question comes under Spark Scala. So here, you need to load the data at the locations user Cloudera problems 1 order as well as user Cloudera problem 1 order items. So the data which we imported using Scoop into the HDFS, we will be using Spark Scala and we will be storing the data that we imported in the form of a data frame. So here I have provided a hyperlink to the data frame. This link will redirect you to the article from Edureka based on Spark data frames. So you can learn more about data frames in this particular article. So moving ahead, we will come across the fourth subdivided problem. In the fourth subdivided problem, we can find the expected intermediate result, which will have order date, order status, total orders, total amount. In layman's terms, we are supposed to find out total orders and total amount per status per day. The result should be sorted by date in descending order, order should be in ascending order, and total amount in descending order, and finally the total orders in ascending. So here we have the first column as order date. So what we are supposed to do here is to arrange the dates in descending order. That means we have to pop up the latest date in the first position, and followed by that we have the order status, which should be in an ascending order. Here the order status should be starting from the lowest number in the order status and it should be ending with the highest number. That's what the ascending order means. And after that we have total amount in descending order. So the total amount in this particular column should be arranged in the format of descending order. And lastly we have total orders, which should be arranged in the form of ascending order. After this, aggregation should be done using the below methods. However, sorting can be done using a data frame or an RDD. So after the columns are arranged, the aggregation process should be applied on all the columns using a data frame or the RDD. Here, I provided a hyperlink to the RDD, which will be based on Spark RDDs, that is the resilient distributed datasets from Edureka. To learn more about RDDs in Spark, you can click on this link and this will redirect you to the article from Edureka. So you can see that this fourth subdivided problem is a bit lengthy and complex. So I suggest you to break it down into more subdivided problems and solve it in a step-by-step way, which we will be solving in the same manner. Now moving ahead to the fifth part, you see that we have to store the packet files. That is, the result of these steps or the fourth subdivided problem should be stored in the form of gzip in HDFS. And after that, the sixth problem is completely similar to the fifth one, but the only difference is here we are using snappy compression. But in the fifth step, we are using gzip compression. So the result for a gzip file will be storing the data frames result, and gzip 4b result will be storing Spark SQL result, and result 4c gzip will be storing combined by key function result. And in the same way, 4a, 4b, and 4c will be storing the results of data frames, Spark SQL, and combined by key data. But the only difference is the compression will be taking place in the form of snappy compression. Once we are done with the sixth step, we will enter the seventh step where we will be storing the data in form of a CSV file in HDFS. And once we are done with saving the data in the form of CSV in HDFS, that is the data frame result, the Spark SQL result, and combined by key result, we will finally enter into the eighth step where we will be creating a MySQL database in the location user Cloudera problem 1 result for a CSV. And after executing all these above steps, we will come into the last step, which is creating a table named result in the location user Cloudera problem 1 for a CSV and store the result into this particular table. Or in other words, we will be exporting the data into this particular table using scoop export command. So without any delay, we will start executing all these steps ahead. I hope we are clear with the problem statement. Now we shall quickly start our Oracle VM VirtualBox. So this particular software is a virtual box over which we'll be executing our Cloudera commands. In order to load the Cloudera onto your Oracle VM VirtualBox, you need to select the option Import. So once after you select the Import option, a new dialog box will appear on your system. So this will ask for the location of your virtual machine. So select the Browse option. Then redirect yourself into the location where your virtual machine is available. So in my computer, this is the location of my virtual machine. So here I'll be selecting my virtual machine and select Open. Once after you provide the location of your virtual machine, the dialog box will ask for the next option. Select Next. And then you'll find the new dialog box on your screen. And remember, here you need to change the size of the RAM. At least you need to specify 8 GB of RAM onto your computer system. So here I'll be providing 9000 MB as the size of my RAM, which is just above 8 GB. So after that, just select Import and your virtual machine will be imported. You can see it is importing your virtual machine. The virtual machine Cloudera Quick Start VM that I'm using is of version 5.13.0. So we can see that the VirtualBox completely imported the Cloudera Quick Start virtual machine. Now we shall just fire it up by just double clicking on the icon and you can see it's running. There you go. Now you can see that the Cloudera has been successfully booted up. Now let's start our HDFS. In order to start the HDFS, select the icon with the name Hue on it. So once after you select Hue, a new web page will be opened and this will be asking you for the username and password. Remember, in Cloudera, the default username is Cloudera and the default password is Cloudera. So let me type in Cloudera as my username. And similarly, my password would be Cloudera. And now, just sign in. You might want to select Remember for remembering your username and password. And there you go. Your Hue got fired up and your HDFS is ready to be used. Now that we have started our HDFS, we're all good to go to solve our first problem. Let's have a look. So this is our first problem here. We are supposed to import the orders table using Apache Scoop as an Avro file. To do so, we might want to start our terminal first. So this is our Cloudera terminal. So the code I'm using here is scoop import. So this particular first line of code will import scoop, and followed by that, we will be using JDBC connection to MySQL to quick start Cloudera 3306 and import the table retail DB. Followed by that, we have username retail DBA and the password is Cloudera. And the table we are looking for is orders. Now, once after we found the table, the next step is to compress the table. So here we will be using the compression of snappy type. So this is the code for that. And followed by that, the target directory in HDFS is user Cloudera problem1 orders. And finally, the last line depicts that the downloaded file will be in the format of Avro data file. Now let's hit enter and see the process. You can see the code has been compiled. This will take a little bit of time since we are doing this for the first time. So the MapReduce has a lot of job to do in HDFS. You can see that the map and the reduce jobs have been started here. Right now they are at the 0%. Slowly they'll increment their process. You can ignore these interruption exceptions. They are just warnings. Slowly the MapReduce jobs are increasing. So finally the tables got imported. As you can see, the terminal says that 68,883 records have been successfully imported. Similarly, the next step is to import order items table into the HDFS into the location user Cloudera problem1 order items. So the code will be completely similar, but the only difference will be the name of the table, which is order items. So quickly let's clear the screen. To clear the screen, you can use Ctrl L, which clears the screen. Now let's write the code. So here we have successfully cleared the screen and the code has been written. And you can see the code is completely similar to the first one. We are first importing scoop. After that, we are connecting to MySQL using JDBC connection and to the database retail DB. Followed by that, we have the username as retail DBA, password Cloudera. And the table we are looking for is order items. And once the table is found, we will be compressing it using snappy compression. And then the target directory in HDFS is user Cloudera problem1 order items. And the file will be imported as Avro data file. Let's fire enter and see the execution. You can see the code is getting executed. Similarly, it will take a little time since we are executing this particular command for the first time. And MapReduce has to do a lot of job to execute this command. You can see the data is been split into 4 splits, and our job is 1576672849094. You can see the map and reduce tasks have started, and they are at 0%, which will be gradually increased. Now you can see the import job is completely finished and the terminal says 1,72,198 records have been retrieved successfully. So with this, we finished the first 2 steps of the problem. Now let us move ahead and understand the third part. You can see the third part is based on Apache Spark Scala. So what we will do here is to store the data that we have imported in the form of a data frame. So the data which we imported was orders, which was the first one, and the second one was order items in the location user Cloudera problem1. So this data will be stored in the form of a data frame using Apache Spark Scala. So to know more about data frames, you can click on this particular hyperlink in the article, which will redirect you to the article of Edureka based on Spark data frames. Now let's go back to Cloudera and execute our third command. Since the third part of the question is completely based on Apache Spark Scala, we might want to open a new terminal and fire up Spark in our Cloudera. So to fire up Spark in Cloudera, the command is spark-shell. So you can see Spark got fired up in the terminal, and the version we are using is 1.6.0. And followed by that, the version of Scala that we will be using is 2.10.5. And we've also got the message saying Spark context available as SC and SQL context is available as SQL context. And there you go. The Scala is ready to be executed. But before we begin with the third problem, remember the version of Scala, which is 2.10.5, doesn't have the internal capacity to load an Avro file. So we have to import Avro files first before we begin the problem execution. So to import Avro files, we need to execute this particular command. So the command is import com.databricks.sparkavro._. So executing this particular statement will give us the capacity to import Avro files. So let's quickly type in Ctrl-L to clear the screen and execute the command. So there you go. We have imported Spark Avro. Now we are good to go with the problem number 3. So let us remember what did the problem number 3 say to us. According to problem number 3, we are supposed to store the data which we have imported using scoop command in the form of a data frame. So here we are creating a data frame using the var command, and the name of the data frame that we are creating will be orders data frame. So the orders data frame will be importing the data from orders table. So this is the orders table location. Now let's fire up this command pressing enter. So you can see the data has been successfully imported in the form of a data frame, and the columns we have are order ID, order date, order customer ID, order status. So similarly, according to the problem number 3, the next step would be importing the order items data frame from the location order items. Let's import the data and put it in the form of data frames. So the command will be completely similar to the previous one. The only difference is the name of our new data frame will be order item data frame, and the location from which we are importing the data will be order items table. Now let's fire up this command and store the data in form of a data frame. So we have successfully read the data in the form of Avro file. Now you can see that the data has been successfully imported in the form of a data frame, and we have the following columns. And you can see we have the following columns. The first one is order item ID, next order item order ID, next we have order item product ID, order item quantity, order item subtotal, order item product price. Now to solve the next step in the problem statement 3, we might have to join both the data frames, which is the orders data frame and order item data frame. So the joining process in Spark is completely easy. So now let's execute the following command to join both the data frames. So this particular statement will help us to join both the data frames. So what we are doing is we are creating a new data frame, which is joined order data frame. And inside that we have the first data frame. So first data frame dot join the second data frame and the columns which you require from the second data frame. Now let's fire and enter and see the output. The join has been successfully applied, and we have the new data frame with new columns present in that. Now after this, we have successfully entered the step 4. So in step 4, the first job was to join the data frames, which we have done. And now the next sub part of the step 4 is to find the total orders, total amount per status per day, and the result should be having the ordered date, the ordered status, the ordered total orders, and aggregation. So the dates should be ordered in the form of descending order. The order status should be ordered in the form of ascending order, total amount in descending order, and total orders in the form of ascending order. Once the ordering is properly done, The next stage is the aggregation stage. The aggregation should be done using data frames or RDD. So we will do this in the form of data frames first. After that, we'll be using Spark SQL. And lastly, we'll perform the same operation using combine key function. So once this is done, we will enter the next stage. Now let's finish off step number 4. So we have come back to Cloudera. Now let's execute the remaining commands. Before that, let's clear out our screen using Ctrl L. Now the complete screen is clear. Let's follow with the step 4. So before we begin, we need to know that we are now working with Spark SQL. To work with Spark SQL, we need to execute the following command, which will fire up the Spark SQL functions. So the command is import org.apache.spark.sql.functions._. So here we have included the Spark SQL functions. Now we can move ahead to solve the fourth problem. So here in the fourth problem, we are creating a new data frame, which is called data frame result. So inside data frame result, we will be storing this particular data, and inside the command, we are using toDate function, and after toDate, we are using an inbuilt function which is called from_Unix time, which is used to write the date in the form of YYMMDD as prescribed in the earlier problem. Followed by that, we're using divided by 1000 here. This is because once you generally execute a command, the date will be executed in the form of a number. So this particular number will be having additional zeros, which is 4 zeros. To eliminate all those 4 zeros, we will be using divide by 1000 number here. And after the command is executed, we will be using alias to rename the column as order formatted date. Similarly, we are using the aggregation function here, and after that we have count distinct, and again we have an alias function which will be renaming total orders in place of order ID. Now we shall fire up the enter key and see the command output. Now you can see that the code has been successfully executed and the data has been stored into the data frame result. Now let's see the data present in the data frame result. To see the data present in data frame result, it's completely simple. We just need to write in show command, and that's how you do it. Now you can see the command has been processing. So you can see the data has been successfully formatted and the date has been arranged in the form year, month and date as requested in the problem. And even we have renamed the column name as order formatted, order status, total amount and total orders. And all the elements are arranged in the form which is prescribed in the problem before. Now with this, let us move into the next step where we will be using Spark SQL and we will be performing the same operation using Spark SQL. Before that, let's clear the screen using Ctrl L. So we have the clear screen now. Now let's type in the new command and execute the next step. Before we begin, we need to register a template because now we will be using the Spark SQL. So to register a template, the command we need to execute is joined order data frame dot register template on the name order joined. Enter. Now we have successfully created our template. Now let's continue with the further steps. So this is the next step that we need to perform. The code is completely similar to the previous one. Now let's fire enter and see the output. You can see the command has been successfully executed. Now let's see the data which is present in our variable, that is SQL result. Similarly to the previous step, all we do is just add in the show command which will show the output. You can see the show command is getting executed. And there you go, we have the table which we were looking for. Let's compare this table with the previous one. The data is completely similar. We have done the same process using different command. Now lastly, we'll execute the same command once again, but using a different method, which is by using combine by key function. So before we execute the new command, let's clear the screen again. Now the new command is based on combine by key function, which is specified over here. Now let's fire up this and see the output. As you can see, the command has been successfully executed. Now let's see the data which is present in combine by key result. Similarly to the previous procedure, we just need to add in the show method. And there you go. We can see that the process is getting executed. Don't worry about the code. We do have this code in our article and you can refer to it. As provided in the question, no need of formatting order date or total amount. So here we have eliminated the stress of arranging our date and formatting the data which we get. So here you can see that we don't have an alias name to our column names and our date is not formatted. But here we can see that the date is formatted. You might have that question, why did we use divide by 1000? So this is the reason behind using the divide by 1000 command over there, which will eliminate these zeros which are present in the date format. So now we have successfully finished the step 4. Now let's move ahead into the step 5 where we'll be compressing all this data. Before that, let's clear our screen. So we are good. Now we shall move into step 5. So what is step 5? The step 5 is all about storing the result as a Parquet file in HDFS using compressions. The first type of compression is gzip compression, and the second type of compression is snappy compression. Now let's execute these commands quickly and move ahead into the further steps. Now we have to remember, to perform Parquet compression, we need to execute this particular command, which will set the configuration that we require. So let's fire enter. And you can see that the command got executed successfully. Now we can move ahead with the compression. Firstly, we will compress the data frame, which is the data frame result, and we will write in it as a Parquet file in the location 4a and using the compression snappy. You can see the process is getting done. You can ignore these exceptions, they're just warnings. The process got successfully completed. For verification, let's get back to Hue and check if this file exists in the HDFS or not. So here we have HDFS problem 1, and inside problem 1, we have our result, which is result A snappy. So this is the Parquet file in snappy compression format. Now similarly, let's execute the next one. Before that, let's clear the screen. So the next command is SQL result.write Parquet file into the location result4b using snappy compression. Let's fire enter and see the output. Now you can see that the code has been successfully executed. Similarly, let's execute the last one. Screen cleared. And the last one is com by key result, which will be stored in the form of a Parquet file as result4c using the compression snappy. Now you might be worrying, why did we not execute gzip format? Gzip and snappy are both similar, or in other words, they're completely same. You can just replace snappy word using gzip and the command will be executed. So to save time, we are just executing snappy over here, but in the examination, you must execute gzip also. Now you can see that the code has been successfully executed. Now we can directly jump onto the next step, which is step number 7. So what is step number 7? Step number 7 is all about storing the result what we obtained in a CSV format. So the results that we have obtained are the data frame result, Spark SQL result, and the last one, combined by key result. So all these three results should be loaded in the form of CSV into the HDFS at the given locations. Firstly, we have 4A CSV, 4B CSV, and lastly the 4C CSV. Let's execute these commands quickly and move on to the next problem. So the first one, here you go. Now you might be having a little confusion, what is x0? So here x0 is none other than the index of the first column, and x1 is the index of the first column, and x2 is the index of the second column, and similarly x3 is the index of the third column. Since the file should be loaded in the form of a CSV file, we need to mention comma because this is a comma separated file. Now the file will be stored in the location user Cloudera problem 1 result 4a CSV. Let's fire and enter and see the execution of this particular command. You can see that the command is getting executed. Now you can see that the command got successfully executed. Now similarly, let's fire in the next command. Now the next command will help us to store SQL result in the location result 4b CSV, which is in user Cloudera problem 1. Now here, similar to the previous one, we also have the column indexes 0, 1, 2, and 3. Now let's strike enter and see the output. You can see that the command is getting executed. Now you can see that the command got successfully executed. Let's fire in our last command. The last command will help us to store the last result, which is com by key result, into the location result 4c as a CSV. Now similarly to the previous commands, we do have the index numbers, that is 0, 1, 2, and 3. And these columns are separated using a comma because it is a comma separated file. Now let's fire and enter and see the output. Now you can see that the command got executed successfully and the data has been stored as a CSV into the location. Now we shall quickly jump into the 8th step. So here in the 8th step, we are supposed to create a new MySQL table with the name result and then load the data from user Cloudera problem 1 result 4a.csv to MySQL table named result. So to do this, we might want to first fire up a MySQL terminal in Cloudera. Then we have to create a new table, and then using the scoop export command, we can directly export the data from the given location to the MySQL table. To do so, let's fire up a new terminal first. Now to solve this 8th problem, we need to start in a new terminal and type in the command in order to get the access to the database retail DBA. So the command will be MySQL -h localhost user retail DBA and password P. So the password is Cloudera, which is the default password. And there you go, we have now successfully entered into MySQL. Now let us use the command to create the table, which is really simple. So this is a create table command, and here we'll be creating a new table called result, which will be storing the particular columns, which are order date, order status, total order, total amount, and the primary key is order date and order status. Now let's fire up enter and see the output. Now the table has been successfully created, and all we have to do is to go back to the first terminal and execute scoop export command. Now we have come back to the first terminal, and all we have to do is to write in the scoop export command, which will go something like this. And before that, let's clear the screen, and there you go. So this is the scoop export command that we need to do here. And let's strike and enter and see the output. And there you go, the command is getting executed and the data is getting exported from the provided location into the new table, which is we created in MySQL. There you go, the number of splits are 4 and the job ID is been provided, which is 157667284094003. And soon we'll be seeing the map reduce tasks to be started. There you go, the mapper and reducer are started. And there you go, they're gradually increasing 25, 50, 75, and the job is done. And you can see the export command has successfully exported 3165 records. And the data transferred is 120.4863 kilobytes in 83 seconds. So with this, we have come to an end of the sample program based on CCA 175 exam. Let's move on to the next part of today's discussion, which is based on the top companies hiring Hadoop developers. So there are a number of companies out there who are looking for CCA 175 certified Spark Hadoop developers. Few of the top-notch MNC companies are Oracle, Medium, Amazon, SAP, Dell, Capgemini, Cognizant, IBM, CGI, Facebook, Accenture, Emphasis, Yahoo, you name it, you got it. There are many companies looking for Hadoop developers in the current IT market. So it's the right time for you to get yourself certified in Hadoop. So now with this, we come to an end of this live session. I hope you had a very sound and good briefing of CCA 175 Spark and Hadoop Developer Certification exam. If you have any queries regarding this session, then please feel free to write them down in the comment section below, and we will revert to you back as soon as possible. My name is Ravi signing off for today and wish you all a very happy learning.